welcome to this class. For today, we'll be discussing an aspect under calculus called trigonometric function of differentiation. Let's discuss the trigonometric function of differentiation. In our previous class, we have discussed on how to solve problem involving the exponential function of differentiation. So kindly check the description of this video. I'll drop the link on how to differentiate term involving exponential function. But for today, let's discuss the trigonometric function of differentiation, right? So when it comes to differentiating trigonometric function, I will give you some 6 parameters or perhaps some 5 or 6 concepts you need to know so we can get familiar to trigonometric function of differentiation, right? And the table goes below. Let's say I'm given y and dy over the x. So I have a table this way, right? So let's say I have y. Let's say y is equal to sine x. So let's say I'm given y is equal to sine x. So my derivative, the way by the x was will be cos x. That's number 1. Number 2, let's say I'm given that y is equal to cos x. The way by the x is what? Minus sine x. Number 3, let's say I'm given that y is equal to tan x. The way by the x is what? Sec squared x. Number 4, let's say I'm given that y is equal to sec x. The way by the x is what? Sec s tan x. Number 5, let's say I'm given that y is equal to cot, right? Cot x. The way by the x is what? Minus cosec squared x. And number 6, finally, number 6, let's say I have that y is equal to cosec x. The way by the x is what? Minus cosec s cot x. These are like the 6 functions and their derivatives you need to know. Note that if I differentiate sine x, I'll have cos x. If I differentiate cos x, I'll have minus sine x. If I differentiate tan x, I'll have sec squared x. If I differentiate cos x, I'll have cos x tan x. If I differentiate cot x, this is sec s tan x. Cot x, I'll have what? Negative cosec squared x. If I differentiate cosec x, I'll have minus cosec x cot x. These are the 6 important derivatives you need to note when it comes to solving problem involving the trigonometric function of differentiation. Let's take an example and let's know how to manipulate using this concept. Let's say example 1. Let's say I have y is equal to sine into log 3x squared, right? Let's say y is equal to sine into log 3x squared. I'm told to differentiate this, right? So what my first task here? First is first, I'm differentiating what with what? I'm differentiating y with respect to x, right? So my first task here, I said when it comes to exponential function, logarithmic function, and trigonometric function, we actually apply the concept of what? Of chain rule. Hence, at this point, my first task is what? Let u to be equal to what? The term in brackets log 3x squared. If I differentiate u with respect to x, I'll have the u over the x is equal to, if I differentiate log 3x squared, I'll have what? 6x over 3x squared. Of course, 3 here 1, 3 here 2, I'll have 2. X cancel out, x here 1, x here 1, I'll have what? X left down here. So 3 here 1, 3 here 2, is 2 here. X here 1, x here 1, and just 1 x here. Right? So I have 2 over x. So this is like a shortcut of solving logarithmic function of differentiation. So I'll drop the link on how to solve problem involving logarithmic function of differentiation. So the shortcut to solve log functions. This is like a shortcut here. Next up, but we said y is equal to sine u. We call this term here u. So y is equal to what? Sine u. Now listen, if I differentiate y with respect to u, I'll have the y over the u is equal to, we just said if I differentiate sine u, I'll have what? If I differentiate sine x, I'll have cos x. Similarly, if I differentiate sine u, I'll have what then? Cos u. So at this point, using chain rule, from what we know, that chain rule is what? Is given as dy over the x is equal to dy over the u times du over the x. Obviously, dy over the x at this point will be equal in value to, we said dy over the u. Check. Dy over the u here, obviously what? Cos u. So have cos u multiplying du over the x is what? 2 over x. I'll have 2 over x. At this point, if I multiply this, I will be having that dy over the x is equal to 2 cos u all over x. I can express x in terms of u, so take u back to x. But we said u from the question was what? Log 3x squared. Log 3x squared. So if I put u here, I'll have that dy over the x is equal to 2 cos u is all this term into log 3x squared. So all over x as my final answer after solving this problem. Let's take yet another example on trigonometric function of differentiation. Example 2. Example 2. This is example 1. That's it. So if I have that y is equal to sec into 3x to the power 3, right, minus 4x squared. So I'm told to differentiate this, that y is equal to sine 3x cubed minus 4x squared. So how do you solve this? How do you differentiate this? First, our first task is to call the term in brackets u. So let u to be equal to 3x squared minus 4x squared. Now, differentiating u with respect to x, I'll have that the u over the x is equal to, I'm applying general method here, of course, general method. If I differentiate 3x squared, I'll have what? 6x minus, differentiate this, I'll have what? 8x, right? From the idea of general method of differentiation. Of course, we said y is equal to sec what? We call this term u. So that becomes sec u. So differentiating y with respect to u, I'll have the y over the u is equal to, we just said that if I have y is equal to sec x, the way of this was sec x times x. Similarly, if I differentiate sec u, I'll have what? Sec u times u, right? Sec x similarly, sec u tan u. At this point, using chain rule, I have that the y over the x is equal to the y over the u times the u over the x. Similarly, the y over the u is what? Is sec u tan u. I'll have let's move there. I'll have sec u tan u. Alright, I'll have that the y over the x, sorry, the y over the u is sec u tan u. I'll have sec u tan u multiplying what then? The u over the x. Obviously, 6x minus 8. That's into 6x minus 8x. I have this. So my y over the x is equal to sec u tan u multiply this. I'll have 6x minus 8x comes out first. Next up, sec u, then tan u. Hence, I can leave my answer expressed in terms of u. Take it to x. But we said u was what from the question? U was 3x squared minus 4x squared. Sorry? Sorry. I'll put the mistake. Let's use square here, please. Square. This please. Let's square here, please. Alright. Okay, let's proceed. U was what? 3x squared minus 4x squared. Right? So, putting u here, I'll have that the y over the x is equal to 6x minus 8x on sec u was what? 3x squared minus 4x squared. Next up, tan u was 3x squared minus what? 4x squared as my final answer after differentiating this term. So let's take one more example and end this concept, right? Let's take yet another example. Example 3 under trigonometric function of differentiation. So let's say I'm given that y is equal to sine squared into 3x. Y is equal to sine squared into what then? 3x. How do you solve this man? The first task is that all the thing in brackets u, as we did initially in our previous examples. So let u to be equal to what? 3x. Differentiating u with respect to x, that will be u by the x, right, is equal to 3. Right? Next up, I have that y is equal to sine squared, we call this what? U. Now listen, for this concept here, from this concept, we said in our first class of calculus that when it comes to chain rule, we call chain rule function of a function or function of several functions, right? So we said chain rule is also called function of a function or function of several functions, right? So I'm going to apply the concept of function of several function here, right? That is, I have y is equal to sine squared u. My task says what? Simplify this. If I have that sine squared u, it simply means sine u all squared. If I have sine cube u per se, this simply means sine u multiply sine u multiply sine u in 3 places. This can be written as, this one can be written as what? Sine u all cube. I'm still correct. This is still correct with this. All this is still correct with this. So note how it works. So if I have sine squared u, it like sine u. So in this case, let v to be one of it, sine u. Right? Say sine squared u means sine u times sine u. So let v be one of it. So if v is one of it, differentiating v with respect to u, about that the v over the u is equal to, if I differentiate sine u, of course I have the cos u, right? So at this point, we said that y, but again, y is equal to sine squared u. But with the sine u, say sine u here to be v, that becomes v all squared, right? So if we take y with respect to v, I'll have that the y over the v is equal to, general method here, I'll have 2v as my answer here. So using chain rule, I'll have that the y over the x is equal to what? Is equal to what? The y over the v first, the y over the v multiply the v over the u, multiply the v over the u, multiply the u over the x, which is obviously this. At this point, I'll have that the y over the x is now equal to the y over the v is what? 2u. I'll have 2v per se, multiply the v over the u is obviously cos u, multiply the v over the x, which is 3 here. Hence, 2 times 3 is what? I'll have 6v, then what? Cos u as my divided by the x value. But we said v was what? V was sine u. So that means that the y over the x is now equal to 6. Then v is what? Sine u, then what? Cos u. But u was said to be 3x. Hence, putting u here, so to have a final answer, that the y over the x is obviously alright. The y over the x is obviously 6 sine. We said u is what? 3x. Then what? Cos u. U is what? 3x. So this is like my answer after differentiating this term, right? In our next class, we're going to discuss much more complex example when it comes to higher part of the trig function. So I'll be looking at much more complex example when it comes to higher index of trigonometric functions.